All right, number 3. If you're having trouble with this, hopefully this video will clarify it. Determine the maximum area of a rectangle with each perimeter round to 1 decimal. So I'm given a fixed or a specific perimeter, and in this case it's 100 centimeters, which means I have 100 centimeters of whatever is going to go around my rectangle. Whether my rectangle is forming a fence for a garden, a frame for a picture, I know how much material I have to go around. I just don't know what it's going to look like on the inside. So if I put this together, hang on, I practiced this. If I put this together, okay, so this is my rectangle. So my rectangle can look like this. It can be very wide. It can be like that. It just depends on what my dimensions are, but my perimeter is always the same because I always have the same amount of string. This isn't a magic trick. I'm not getting more. I mean, sure, I can stretch it, but I'm not getting more string. It's always the same amount of string. It's just a matter of how I'm going to set it up so that it forms a rectangle, and how I'm going to maximize that area, get the optimal area to be the greatest. So we learned through the investigation that the shape that has the maximum area for this perimeter is a specific type of rectangle, and that is a square. So if I make this into a square, I know that I'm going to have the maximum or the greatest possible area. So if this is 100 centimeters, and I want to make it into a square, that means every side is going to be the same. So in order to get every side to be the same, I'm going to take that 100 and I'm going to divide it by 4. Because if I cut this into 4 pieces that are all the same, I'm going to make a square. So I'm going to take 100 and I'm going to divide it by 4, and that gives me 25. So that means for this square right here, all of my side lengths are going to be 25 centimeters. Okay, so what this looks like drawn is I have a square. So this is going to, actually it is to scale because I'm making it 2.5 instead of 25 on each side. If you're doing your sketches, I imagine that most of you are probably not going to use a ruler, but the nice thing of a ruler is that ideally it'll be straight. Okay, so this is 25 centimeters, and it's like that on each side. Remember, these lines mean that it's all the same. So the question is actually asking for the area. I found that the side length is going to be 25. So area is equal to length times width. My length is 25 and my width is also 25 because it is a square. So the length and the width are the same. That's part of the characteristics of a square. So I'm going to say 25 times 25, and that gives me 625 centimeters squared. So that is the biggest possible area. If I were to go through that whole process of that chart that we did in the investigation, I would find that the greatest possible area is 625, but I don't need to do that because now I know that all I need to do is take the perimeter, divide it by 4, and that gives me the dimensions of the shape, so the different sides, and I can use that to find the area. Same thing with B. So this time my string is 72 centimeters. So I'm taking that 72 and I'm cutting it into, or dividing it into 4 equal pieces in order to make my square. So 72 divided by 4 will give me 18, I think. Yeah. So 18. Again, I'm going to sketch. This time it's not to scale. I'm making all my side lengths 3 centimeters just to make them the same, but I could have also just done a freehand. It's just that this looks nicer. Okay, so all of the sides are the same because it is a square, and they are, it's 90-degree angles. It is 18 meters. So my area is equal to length times width. Or you can even say that your area is equal to S squared because it's a square, so the side lengths multiplied by themselves. So I can say 18 squared. Instead of writing 18 times 18, I can just write 18 squared. Just like here, instead of writing 25 times 25, I can just write 25 squared. So 18 squared gives me 324 meters squared is my area, my maximum possible area for this specific perimeter.